It's fraction time. I'm Miss Aker. Welcome back to my classroom. We're going to get started with Just Know It, the first part of our lesson. And today we're going to get ready by just knowing our multiplication facts. I have some facts here for you, and I just want you to say it right out loud as soon as you know it. Tell me that answer to the multiplication fact, the product. Here we go. Last one. All right, did you get those? Let's see if you knew them. First one, 3 times 3, 9. Nice job. 6 times 2 equals 12. Excellent. 5 times 3 equals 15. 2 times 4 equals 8. And last but not least, 4 times 4 equals 16. Way to know your multiplication facts just like that. And if you didn't know them just like that, you can practice at home to get your automaticity and your fluency with your math facts down just like that. All right, it's time to move on to figure it out. And today I have a word problem here that we're gonna figure out together. Zaire walks 2/3 of a mile to football practice and 2/3 of a mile back to his house. Practice is on Tuesday, Thursday, and Saturday. How far does he walk in a week? Well, we know read, think, draw, write. So far, so good. Let's underline some important information in this problem. 2/3 of a mile and 2/3 of a mile. So he walks 2/3 there and 2/3 back. Let's keep that in our minds, that visual. Real fractions in the real world, distance. And he has practice Tuesday, Thursday, and Saturday. That's 3 days out of the week he has to practice. How far does he walk in a week? Okay, so I know he has 2/3 plus 2/3, and that's each day he goes, and that equals, if we know we just add the numerator, that is 4/3. But he doesn't just do it one time, he does it 3 times. What should I do? Okay, I'm thinking about multiplication. I could do something with multiplication. I could add it, so we have Tuesday, we have Thursday, and we have Saturday. 4/3 plus 4/3 plus 4/3, and that equals, well, it's 4 3 times, and 4 times 3 is 12, but it's not whole numbers. It's fractions, so 4/3 3 times 4, 4, 4, 4, 8, 12. Oh, it's 12/3. He walks 12/3 of a mile. That sounds kind of weird. How would you put 12/3 into a whole number? Oh, I know. It's like putting 12 divided by 3. He walks 4 miles. Wow. That was an interesting figure it out. We took addition and multiplication and we put them together in the same problem. There are lots of different ways to solve this problem. You might have solved it a different way at home. We're to the next part of our lesson, which is what's new. We're going to use some of what we did with Figure It Out to talk about what's new today. I can use models and symbols to multiply fractions by a whole number. Let's break it down. So I can use models. Well, we know we have area or bar models, we have number lines, we have fraction strips. Look at all the models we know. So models are our drawings. And symbols. Let's come back to symbols. To multiply, well, we know multiplication. That has the multiplication sign, and it has factors, and it has products. And multiply fractions, numerator on top, denominator down. Frankie will never leave us. By a whole number. Well, a whole number is not a fraction. It's like 1, 3, 4, 7. All of those are whole numbers. They're not fractional parts. Okay, so we're going to use models and symbols to multiply fractions by a whole number. Well, I think some symbols we could use are multiplication symbol, an equal sign, things like that. Those are symbols. So let's get started on solving some of our what's new problems. For what's new, you always need your piece of paper, your marker board, something to write with like a pen, pencil, or a marker. All right, let's get started. We have some bare numbers today, and we are also going to do some word problems with read, think, draw, write. So let's just practice. So in that problem with Zaire, he was walking 2/3, and we figured out that it was 4/3 each day, and we just multiplied or added together the numerator. So with this one, we're gonna, it's 4 copies of 2/3. So another way of looking at it is 2 times 4 over 3. So we only multiply the numerator and we get 8/3. Or we could think of it as 2/3, the unit fraction of 2/3 is 1/3 times 2, because there's 2 of them, and that times 4. So we know that here is our 2/3. 1/3 is the unit 2 times. I'm going to try putting it like this. 1/3 times 2 times 4. So now I can take 2 times 4, that equals 8, and 8 times 1 equals 8/3. So we end up getting the same thing. 2 different ways of solving, but we're just looking at that numerator and the whole number to multiply. Let's do these. So 4 times 1/3. 4 copies of 1/3 equals 4/3. 7 times 2/5. 7 copies of 2/5. Know your multiplication? Just like that, 14/5. 3 times 5/8. 3 copies of 5/8. 15/8. Nice job with those bare number problems. Let's try a word problem. Asa ran 5 laps around the school track. Each lap is 3/10 of a kilometer. How far did Asa run? Well, read, think, draw, write. All right, so we read it. So we know 5 laps is important, and we know every time he goes around, here's an image to help us. Every time he goes around, that's 3/10 of a kilometer. So one circle around is 3/10 of a kilometer, and they even included the abbreviation. How far did Asa run? So we want to know the total distance. Okay, so we could draw a number line, we could draw a bar model. I'm going to do a number line. So we have 0 and 1 and 2. So I'm going to break this down into 10 parts. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When you draw it yourself, it's a little hard to get it perfect. It's good to use number models or number lines that your teacher might have for you to help you get it accurate. So let's jump 3/10 5 times. So 1, 2, 3. So that's 3/10. That's one time, one lap. 1, 2, 3, 3/10. That's the second lap. 1, 2, 3, 3/10. That's the third lap. He has 2 more laps. 1, 2, 3, 3/10. That's the fourth lap, last lap. 1, 2, 3, 3/10. And that's the fifth lap. So this is where Asa the total distance would be. So let's figure that out. 3/10, 3/10, 3/10, 3/10, 3/10. So we could add these. We could count 1, 2, 3, or we have 1, 2, 3, 4, 5. We can use symbols. So 3/10 times 5 equals 15/10 of a kilometer. So we have, let's double check, 3, 6, 9, 12, 15. And here was 1, so 1 and 1, 2, 3, 4, 5 kilometers. 1 and 5/10 kilometers. All right, let's try one more together. This is my favorite kind of fraction problem, one with food, especially brownies. Okay, let's RTDW. Evan cut the pan of brownies into 9 squares. Oh, just like this. I see 9. He served 1 to his twin brother, 1 to his mom, and 1 to his other mom. He ate 1 too. Okay, brownie party. Write a multiplication equation to show the fraction of the brownies the family ate. Okay, so we have to figure out the fraction of the brownies, the total amount of brownies they ate. So you know what? I just need a little visual. So I need Evan. This just helps me. His twin brother, T for twin, mom, and his other mom. Okay, there's 4 of them, and there's 4 brownies that they ate. Yum, 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 yum. Okay, so I'm gonna write a multiplication equation to show the fraction of the brownies they ate. So each of them ate 1/9, because each of these parts is 1/9. So they ate 1/9 of these, and there's 4 of them. We're gonna use that symbol. So 1/9 times 4 equals, and let's just put a B for brownie. B equals brownie. Use a letter there to show our equation. So we remember we multiply the numerator times the whole number, and we get B equals 4/9. They ate 4/9 of it. Can you figure out how many brownies they have left? What fraction of the brownies they have left? Bonus challenge. Let's write a sentence. The family ate 4/9 of the brownies. All right, again, I like to box my answer just so everyone knows, and we got it. And it's time for Try It, where you get to give it a try at home with some problems and challenges I have for you right now. So first, I have some bare number problems. 6 times 4/5 equals something, 3 times 2/10 equals something, and 5 times 3/4 equals something. See if you can figure out those bare number problems. Extra challenge if you can write a word problem to go with these bare numbers. And then I have a special little word problem for you here. A baker uses 3/4 brown sugar for each batch of cookies. How much brown sugar will the baker need for 3 batches? 4 batches? 10 batches. That's a lot of cookies, but sounds delicious. See if you can figure these out and share them with us on our social media platforms. Can't wait to see how you do with that. Oh, that time once again. Today, I want to teach you a new call and response. When I say all set, you at home say you bet. Here we go. All set, you bet. Thanks again for watching.